All right, ladies and gentlemen, I'm going to use this video to go over the study guide. You should have already watched the first two review videos on the learning targets. Those go over stuff in a little bit more detail. Now I'm just going to try to quickly go over the things in the in the study guide and where you would find them. The first question is actually pulls a whole bunch of things that we've been talking about together. So it's located in several different places. It says place the following items from smallest to largest. Well, prions, those were talked about in your virus notes. Prions, it says here, are smaller than a virus, so small that we haven't even really seen them yet. And then viruses are a little bit bigger. Viruses are just DNA and RNA surrounded by a protein coat. So prions are just protein. Viruses are DNA and RNA surrounded by a protein. And then bacteria, remember that bacteria are, give me a second to get to the right slide. Bacteria are prokaryotic cells. Pro means before nucleus. They are small cells. Eukaryotic cells, which is what human cells are, have a true nucleus and they're enormous. They have mitochondria and a nucleus, and some have, plant cells have chloroplasts and Golgi and endoplasmic reticulum. So the order would go prion, just protein, virus, DNA and protein, bacteria, prokaryote, and then eukaryotic cell would be the human cell. That was from smallest to largest. Okay, in the next section, it's a matching about the bacteria. We already said a couple of them. Prokaryote means before nucleus, so they're the ones that evolved on this planet before there was such a thing as a nucleus. Eukaryotic are the true nucleus cells, so that's like human cells. And then when we focus in more on the bacteria, the eubacteria are a domain of bacteria that we do come in contact with, and about 1% of them make us sick. Some of them help us, and some of them couldn't care less about us. They don't have anything to do with us. The archaebacteria are the ancient bacteria. They live in more extreme environments. We generally don't come in contact with them. And there was only three things I needed you to know about them. I needed you to know about methanogens. We know that they live in the guts of cows because they make methane when they toot. The extreme halophiles, halo means salt. They love salty environments. And then the thermoacidophiles, they love hot acidic environments like hot springs, volcanic vents, that kind of thing. All right, in the number 8, it says, in 2 sentences, compare how bacteria make us sick to how viruses make us sick. So I'm going to see if I can scroll around here. I'm in the bacteria notes. The way that they make us sick is they release toxins. That's very, very different than the way that viruses make us sick. Viruses cause our cells to burst open. So bacteria kill our cells by giving poisons, and then viruses cause our cells to explode. I'm pointing to my throat because it can give you a sore throat depending on which way it's making you sick. Okay, and then in 2 sentences, explain, that's from our bacteria notes, explain how antibiotic resistance happens. So antibiotic resistance is when we use an antibiotic and it kills the weak bacteria and it leaves behind any bacteria that might be resistant to that antibiotic. Your immune system is supposed to eat them. However, some people's immune systems are weak, and so those strong bacteria might not get killed by the immune system, and then they go on to reproduce. And that's a resistant strain of bacteria, and that's an antibiotic resistant strain, and that antibiotic doesn't work on that strain of bacteria anymore. All right, on to the true and false section. Antibiotics are effective treatments against bacteria and viruses. False. You should cross off the word bacteria. Antibiotics are only for bacterial infections. They do nothing for viral infections, which is what most of our colds are. Number 11, completely finishing an antibiotic prescription it helps prevent antibiotic resistance. That is correct. If you don't finish the prescription, then it can those resistant bacteria can start growing in your body again. You need to get rid of the other ones so that your immune system can take care of those resistant ones. Okay, scientists believe the nucleus was once a bacteria. That is falso. They believe that the mitochondria was once bacteria. It's the same size as bacteria. It has its own DNA. It divides on its own. It has its own ribosomes. Number 13, the capsule of a bacteria helps it stick to surfaces. That is absolutely correct. And it's part of the reason that we use soap. Soap makes our hands slippery so that the bacteria just slides off our hands. Number 14, bacteria clone themselves through the process of binary fission. That is true. They are clones, so they can't make new DNA except through an accidental mutation. So then we studied different ways that they can get new DNA by sucking up the DNA of bacteria that are dead, or by exchanging DNA with a different bacteria, or by getting DNA from a virus that picks up the DNA from one bacteria and gives it to another. All right, it says some eubacteria help us to make vitamins, and that is absolutely correct. So, right behind my head here, I don't know if I can move it, but oh no, sorry, it's up higher. Help us to make vitamins, do good things. Lots of eubacteria help us do good things. Number 16, viruses are alive is false. We say that viruses are not alive. They do have DNA, but because they're not made of cells, because they can't do any of the other cell processes of life, they don't currently fit into our definition of what's alive. Number 17, it says, I'm going to scroll this up a little bit. Viruses are made of DNA and RNA and proteins, and that is a for sure true. So there's, oops, in this diagram here, there's the DNA or RNA surrounded by a protein capsid. And 18, outside of a virus is called a capsid. Just said it. So that's true. Number 19, the lytic cycle of a virus begins immediately, whereas the lysogenic cycle may take years. That is true. This is the lytic cycle where the virus injects its DNA. The DNA says, build more viruses, and then your cell builds 10,000 viruses in one cell, and the cell bursts open. That happens in a matter of, I don't know, 24 hours. It would depend on that. It would depend on the virus. The lytic cycle, whoops, going to go one more screen here. The lysogenic cycle is just a delay in the lytic cycle. The virus in the lysogenic cycle remains dormant days, weeks, months, years, and then it's triggered by some event, and then the lytic cycle starts. So it's just a time delay between the two. All right, number 20, we can skip. It was smallpox, just so you know. 21, tiny infectious proteins called prions. Sure enough, that's what we talked about. May cause holes in a patient's, not in their muscle tissue. It makes holes in a patient's brains. It causes what are called contagious brain diseases or transmissible encephalopathies. And then you don't need to know 22 or 23. Those are ones that we didn't get to this year. All right, the immune system review, let's go over that. So it says fill in the blanks using the word banks. The cells of the immune system, I'm going to go over to this one. The cells of the immune system are called white blood cells, and they recognize and attack foreign proteins. Here are the foreign proteins. They're called antigens that are on the surface of disease-causing bacteria and viruses. They may even attack the foreign proteins of a healthy transplanted organ, even though it is not a pathogen. Organs don't cause disease, but anything that is foreign to the body is called an antigen. All right, and then for the non-specific immunity, question 25, skin, mucous membranes, and stomach acid are all part of the body's first line of defense that works to prevent pathogens from ever entering or reproducing in the body. If the skin is penetrated, let's go to the next section, inflammatory response increases blood flow to the area via the chemical histamine, and white blood cells engulf any pathogens. There's the neutrophils that we call the kamikazes because they drop this bleach-like chemical that kills those cells and themselves. If an invader makes it in and begins to reproduce within the body, a low or moderate, let me turn to it, fever may occur, helping the white blood cells to divide and slowing the growth of some bacteria. And then specialized white blood cells begin to attack, and that's where we start talking about the immune system. So let's go ahead on to number 26. Giant eaters, that's what the name means, called macrophages, swallow the pathogens. These giant eaters then call in their generals. The generals are called the helper T cells. I use the word general because it reminds me of like a war that's happening. And the helper T cells then tell all the other white blood cells what to do. Remember with HIV that those helper T cells are killed, so they can't tell the immune system what to do. All right, it looks like my recording is going to end in just a minute. I'm only allowed to record 10 minutes at a time. So I'm going to stop here and then we'll finish. We'll start up on the second review second review video on question 27. All right, see you in a moment.